27, letter A. What do the four angles in the above problem become if a 5,000 line per centimeter diffraction grating is used? All right, so these are some of the values from the last problem. Let's put them on over to the side. These were the wavelengths with their associated angles. Okay, so now what we're going to do is we're going to take these angles and use them in our formula. Excuse me, these wavelengths. Okay, so the first thing is, please review number 26, by the way, because I'm really going to run through this one. So the distance here is going to be the centimeters, 1 times 10 to the minus 2 to convert that into meters, over then the number of lines, 5,000 this time. So that's going to be about twice the amount that we had in the last problem. So this is 2 times 10 to the minus 6 now. What I'm then going to use is the constructive formula d sine theta is an equal to m wavelength. I'm solving now for the angle, so divide this on over and then inverse sine it. Oop. So you can get rid of the sign on the left. And now this is just the angle. Okay, so here's the thing. When we now plug in our values, this is going to be inverse sine. The m is the first order max that comes from the last problem. Okay, now I'm going to plug in the wavelengths that I found. So this is 4.10 times 10 to the minus 7th, all divided by then the d, which is the 2 times 10 to the minus 6. Okay, and we're just going to take out the calculator. Make sure your calculator is in degree mode, by the way. I was just doing calculus before, so yeah, thank goodness I remembered. So inverse sine. So inverse sine of 4.1 times 10 to the minus 7th divided by 2 times 10 to the minus 6th. And here we get now about theta will be equal to about 11.8. All right, degrees. So that now becomes the new value. All right, that was for the first wavelength. So maybe what I'll do, why don't we try to do this? Let's move this over a little bit. Let's move this over a touch. And I'm going to expand on this, okay? So we'll put this value, this is the new theta, all right? And then let's do it for the next one. So the only thing that's going to change here is now the wavelength. So this becomes 4.34 times 10 to the minus 7th. So now just redo the calculation, inverse sine, 4.34 times 10 to the minus 7th divided by 2 times 10 to the minus 6th. And that's now 12.5. So this is now 12.5 degrees. Then do it for the next one. So that becomes basically 4.86 times 10 to the minus 7th, okay? So inverse sine of 4.86 times 10 to the minus 7th divided by 2 times 10 to the minus 6th. That's about now 14, right? So 14.1 degrees. Last but not least, plug in the new value, the 6.56 times 10 to the minus 7th divided by then, we'll inverse sine it. So inverse sine of 6.56 times 10 to the minus 7th divided by then 2 times 10 to the minus 6th, 19.1 or so. All right, so those are the answers for letter A. And then letter B, using this grating, what would be the angles for the second order? So now what's going to happen is you have to plug in a 2 here, all right, in your formula. So you got to redo everything, okay? I'll put it, so now in this formula here, you got to have a little 2 times now in the numerator, all right? So you got to redo everything now. All right. Yep. I'm just going to put it right below. Okay. So the first one is going to be inverse sine of 2 times. Actually, could I just go back in the history? That might be a little easier. Yeah, let's do that. Let's go back in the history. And we're just going to plug in a little then in there. Insert now. 2 or times. Oh, no. That didn't work as well as I wanted. Never mind. All right. Inverse sine of 2 times 4.1 times 10 to the minus 7th divided by 2 times 10 to the minus 6th. So this is 24.2. So theta here will be equal to 24.2 degrees. Wait a minute. That's the same as this. Huh. What do you think is going to happen as I keep going? Guess what? They're all going to be the same. Okay. Check it out for yourself. Do the calculations. All right. The next one's going to be 2 times this then wavelength. All right, see what you're going to get divided then by the 2 times 10 to the minus 6. See what you're going to get. They're all going to work out to be the same as the prior answers from the first problem, okay? All right, so then notice that then what is part C saying? Discuss the relationship between the integral reductions in lines per centimeter and the new angles, right? So so here were the old angles. As we then reduced the number of slits, the new angles then decreased. Okay, and then as we increased then the order of the maximum here, right, the angles then went back. Basically, they kind of went from a lower angle then to a higher angle. And they equaled then the angles from the prior problem. So, all right, cool, guys. Thanks for tuning in. Appreciate it. Yeah, you know how I feel about this one. We'll see you soon.